I'm gonna see if anyone else comes in, but it doesn't look like we're gonna get a lot of people in right now. At Labor Day weekend and everything. Alright, well this is recorded and you'll all be able to review it, so I'm gonna get started. So, as you guys can tell, today we're gonna be talking about loops, arrays, and functions. Loops and arrays are pretty easily associatable, and functions is something that I want to get you guys started in, but it's definitely a lot different from the other two. So, the basics of a loop. Last time, we had gone through the while loop thing, and you guys had learned how to repeat logic, and that is the basic idea behind loops. The big difference between that and loops based around arrays is that a while loop really cares about a single condition. Technically, a for loop does also, but the big thing here is that the for loop, it's much easier to it's better when you're trying to compare it to array indexes, which we'll get to later. So something that you guys will definitely be having to do, and I just wanted to bring it up, is a nested loop. The idea that a loop can go inside of another loop. When you're putting a loop inside of another loop, it's easy to say verbally, oh, well, the loop will go, and then it'll get to the next loop, and it'll run that until it needs to stop, and then it'll go to the other stuff, and then it'll loop again. But the bigger issue is that when you actually try to implement this, you'll find that it's not very intuitive. Trying to think about when to do these kinds of logical things, it might make sense for instead you to see oh, well, while main menu, why wouldn't you just put this before the game? And you might be right. That might be the time to do it. That might be a place to put it. But more so, what you should be asking yourself is, how would I utilize these loops? How would I utilize this nesting logic? In the project that we're going to be doing, you're going to have to end up doing that. You might be able to get away with it, but it'll be a lot easier if you just put a nested loop in. Alright, so the big thing that I want to talk about today, these are called arrays. Now, arrays are a special type of variable. Normally, when we have a variable, we just have a single thing, a single number, a single string, a single character. But an array allows us to, in one single place, using one variable, keep a collection of items, keep multiple things together. So if you see in this example, I made just the one int, but then I made an int, and then that's these two brackets next to each other, int, bracket, bracket. That's how you declare an array. I said small int array, and then you can see instead of giving it one number, I put these curly braces, and then I had to give it more numbers. I gave it a 6, 7, and 8, and then I also used a variable here because one int can go into a collection of ints. Then I made another one down below it. This one I didn't fill it up with anything. I just said make it a new int array of size 5. And to be honest, there's a lot of small little things you can do with arrays. It's better for you guys to find these out just by Googling and looking up algorithms that people are doing and things like that than it is for me to try to blow them up and just explain all of them. If you don't need certain parts of them, there's no reason for you to know all about it. It's just going to add extra stuff in your brain to confuse you. But the big thing here to remember is that arrays are like a variable, except they contain many instances. So let's make one. Let's do int test1. That's 5. Int array test2 equals test1. Alright, and now let's put a breakpoint. Alright, so if we look at test1, it just says 5. By the way, what I did here is it's called a breakpoint. Most IDEs have this. If you don't know how to set that up, there's a lot of good YouTube tutorials. I can also walk you guys through it. But the main idea is you put a little on the side, you click this dot, and then when you run it, your program stops on it. And you can use these controls to step forward and look at data. So here we go. an int, just the number that we've all been familiar with. But the array says count 7, and that matches up, 1, 2, 3, 4, 5, 6, 7. You drop it down, and now you can see all of these things inside of it. Now, the thing about arrays is that in order to use them, you kind of need to, at one point or another, you kind of need to add extra steps in. You can't just take one. You can't just just apply anything to it like you could a normal int. You can't add two arrays together, for example. I mean, you can, but it's complicated. So the way that we do that, and I'll put this in the slides too. Say we want to make another int. We want to pull one out of this array. We can go int test3 equals. And then normally we could just say test1 if it was a normal int. But if we try to do test2, it won't work. If we highlight it, it says it's not the right type. Yep. So the way that we do that is we use those brackets that we learned before, and then we give it a number. But then that represents the place. So if we say 0, that's the first part. That would be test1. If we say 1, that's going to be this part, the 6. Also, remember everybody, arrays start at 0. I'm going to close that out. So that's how you can actually get the single instances outside of an array. Here I just talk about how they're just the same as a normal variable, but build them out into a collection. Oh, and this is actually important, array length. So this is how you can, when you're doing iteration stuff, figure out how many times to do something. Also, fun note, it's an int. Test2 dot length. So if we run this, test2 has a count of 7, its length is 7, the variable length 7. You'll use that. Well, when we get to for loops, that'll make a lot more sense. I won't even keep explaining it right now. I prefer calling them functions, but y'all can do whatever you want. Methods and functions, I think, are the same thing. And if they're different, then it's never come up. Oh my god. I see what you mean. Let me see if this fixes it. Alright, well, whatever. Misspelled. Laugh at me. For loops. Okay, for loops. This is the cool shit. So, for loops are a way for you to deal with arrays in its entirety. You can take pieces of an array and add them all up, find an average by adding them to an amount. You can put other for loops inside of for loops. If you want, you can make an array of arrays. I'll actually show you this. I won't make you guys do this right now. Eventually you'll have to, but I'll show you. This is pretty cool. Oh wait, maybe I can't do that in C#. No, I can't. Shit. Alright. You do it like this then. No? Uh-oh. Well, I'll Google it. Actually, here, you guys can see my Google Foo in action. Oh. I got it. Okay. I just don't put the numbers here. So then, now I can do something like iterate 3 times and then, go down it 4 times. And then I'll be able to get through all 12 of the spaces through just 2 for loops as opposed to, going through... Oh, yeah, I'll zoom in. I forgot to do that. I usually do that. Thanks for reminding me. The multiple dimensions thing, especially if you're working on like a grid or like 2D space, like with physics, like platformer physics, stuff like this is pretty integral and critical. Stop typing with your chin. Yeah, I feel that. I have a loud keyboard. All right. So for loops, the thing about these is that they look really, really fucking scary. They've got like a declaration, a semicolon, but then more stuff on the same line, parentheses, and then brackets somewhere. It's a messy thing. So crutch with your tab button when you're in your IDE. Most of the time you can just be like hit tab and it fills in a lot of it. But for sake of education, I will go through it manually. So anatomy of the for loop. The first part, we have the declaration. Now this, you don't actually have to do anything. However, you'll always be doing it, otherwise you shouldn't be using a for loop. The declaration here is to give you an integer, usually, that you can use to keep track of how far along you are in the for loop. Sometimes you start at a 0 if you want to count up. Sometimes you start at like the maximum and then you count down. But there's a lot of things that you can do with these for loops, and for now just stick with this, but if you want to experiment you'll discover there's a lot more you can put in here. The condition to keep going. This is kind of like the while loop. This is actually, this portion, this I up to the semicolon, is exactly like a while loop. As long as this is true, you redo the loop. And then this is, I don't actually know what it's called, I don't know the technical term, but it's what the for loop will do once it runs through all of its logic. If we go, when I do a breakpoint and I run through the for loop manually, you'll see it'll do all the code and then run this. So in this case, I said I++, which is a nice way to say I equals I plus 1, or I plus equals 1. Basically add 1 to I. But the idea here is that each time we increment I by 1. So we'll have I, we'll run through logic, add 1 to it. Then how we can actually use I. I don't know if I put it in this thing. Yeah, I did. Okay, I did. So let's, this is actually, now that I look at it, this is a pretty poorly written one. So let's take this. Let's remake this into just one dimension. So, for loop. For int I is equal to 0, because we're going to count up. I is less than test2's length, and I plus equals 1. So, say we just want to do something simple. We want to print out each index. Console.write line, and then we'll do test2. Now, do you guys remember how you can index into this with these brackets followed by a number? That's what we're going to do here. So test2, but instead of putting in an actual number, we're going to use the variable I. Now, what this will do is every time I changes, it'll change here, and then that'll change which index we access, which will change what we write. So in a very simple way, I've written like console.write line. I've written this, but for each one. But instead of having to rewrite it, even though I just did, instead of having to rewrite it, we just put it into this loop, and it runs through and it does a logic for us. So I'll stop talking, I'll run through it, we can actually see what it does. Okay, so first off, let's see what test2 looks like. Open it up. It looks like exactly what we want it to. It's got its numbers in order. 0 is 5, it's 5 there. 4 is 100, 100 there, everything else in between, good. Okay, so for I equals 0, good, makes it I equals 0. It's going to check. Currently I is 0, the length is 5, 0 is less than 5, do the code. Console.write line, I is 0 in this loop. It'll write that line out. I plus equals 1. See how it did that after the code? Now we go back to here, check again. I is equal to 1 less than 5. Write it out. I is equal to 2 less than 5. 3, 4, and then 5. Now, because I was 5 and length was 5, it wouldn't do the loop. So now we finish running it. Look at our console. There we go. 5, 6, 7, 8, 9, 100. So this idea of iterating through arrays is basically, it's kind of the core of how you use arrays. No matter what you do, if you make an array, at some point you're going to want to go through, check its length, and do something for each instance of its length. Otherwise, it might as well have been a single variable. So the thing here to remember about for loops is that this is not scary. It just looks like a lot, but the more you do it, the easier it'll come. So functions. Now, here's where a lot of people make things easy for themselves, and a lot of people just lose their shit. Functions are a way for us to take a block of code that we like, that we use a lot, and put it in one place. And then instead of copying and pasting the code everywhere, we can just call the function. It'll do it for us. There's other benefits to it, but that's the real big part. The best way, I guess, to approach functions is to think of it like this. Let's take a block of code that we want to do. Say you're working for a math professor, and he wants you to figure out how to calculate really complicated things. So he gives you, int a, and he's going to tell you what to set it to. And same thing with int b. So, also, if you haven't finished the first assignment, this is a cheat code. You can use this to grab ints from the console pretty easily. It'll break if you give it the wrong thing, but so int a, int b, he's going to give it to us, and then he wants us to add it. So we would do something really simple, like console.writeLine a plus b. And then it would add it for us. But then he wants to do it again. He's going to give us another set of integers. C and D. And we have to do the same thing. So as you can see, I've got a block of code here, and I've got a near identical block of code here. There's a way that we can make this faster, a way that we can make this easier, more readable, and also more modular, which is something I'll get into in a little bit. We can make a function for it. So let's look at this, and let's try to figure out exactly what the main components are. So int C and D, or in this case, int A and B, are basically the same thing. They're just two ints that we're going to add. In fact, I'll make this a little bit easier. Instead of console.writing, it'll write answer 1. So the main thing here, A and B, you get from the console. And then we store them in an answer, we print the answer. So this pattern repeats here. If you look and gather these kind of core components, you'll see that we have the first int, the second int, and then a result. Now, the way that a function works, if we go back to the slides, functions, you've actually used them before in the console.write. Functions take in arguments, separated by commas if there's more than one. and then they can do stuff with those arguments and then return something. So let's break down how this function gets built. So public and static are two things that I can get into, but they're not super important for now. Just make sure that you put them in, or your functions probably won't work. So public, static. So then the first thing that we want to do is figure out what we're going to return. Because we know that the end result of this is we want to have an answer between adding two integers, we're going to return an int. That just means that this function will end up spitting out an int, the same way that readline spits out a string. So int, and then add two numbers. Okay, so here it'll yell at us. It says return statement is missing. Now if we add that, this function would work. What this function will do, and I'll run us through it. Console write line function. Oh, it's waiting for us to give answers to. Okay, that was a little confusing. I'll drop these out for now. It prints out 0. If we put a breakpoint here, and also put one in here so you can see it, trace through. Function int doesn't have anything, it's just set to 0 because that's the default integer. And then we go into the function, it'll return 0. Function, it stays 0. Okay, that's a bad example because you can't really see it do anything. So let's do this. Okay. Function int is at 0 because it has not been turned into anything. Go in, it returns this, which means now it'll spit it out to function int, set it, and now it's set to something else. That gets printed to the console, and there you have it. So now we want to use arguments. We don't just want a function to do a simple thing like this, like just spit out the number. We want it to do some logic. So in here, when we're defining a function, we have to define, or we put our arguments in here. Int, give it a name, give it another name. So let's say we wanted to add them, like the function name would apply. And then instead of returning that, we'll return answer. This yells at us, that makes sense. We need to give it two numbers, 5 and 6, let's say. We'll break it down. Okay, function int's at 0, goes into the function because we called it, and we get answer is 0 because it hasn't been made yet. Number 1 and number 2 are the 5 that we gave it and the 6 that we gave it. Notice how they keep the order, that's important. And then now answer becomes 11. We return answer, spit it back out. Function int becomes that answer. And now we can use it like we normally use any integer. So in this way, functions are able to take these big blocks of logic and make them easy to reuse. Let me think of a more complicated one. Let's do this. Average two numbers. Actually, we'll make it average numbers, and I'll give it an array so you guys can see on camera how to deal with arrays before you attempt it yourself. So instead of taking in, I'm just going to delete all these. We're not going to use them again. Instead of taking in two numbers, let's say we take in integer array of numbers, and we're going to return just one int because an average isn't an array, it's just one number. So the way that I would do that, I would first int total of all numbers and make that 0. Start it off at 0. For int I equals 0, I is less than array of numbers dot length, addable to I. We are going to say total of all numbers plus equals array of numbers at I. So if I break this back down to English, the way that it works is total of numbers will add each subset of array of numbers, each index, each individual piece of data stored in that variable. The end result is that at the end of this, if I were to just return total of all numbers, I'll make an array here so we can start testing it. If I just end up returning this at the end, it would be the result as if we added them all up together. I'm not going to go through and do the quick math, but let's say it's this. One, two, three, four, five, should be 5, and it's 5. So again, if we go through the for loop, we'll see that it does exactly what I said it does. It goes through, total of all numbers is nothing right now, added up, and that added 1, because array index 0 of array of numbers is 1. You know, rinse and repeat, it gets all the way up to 5. And then we write it out to console. So, you know, now I'm gonna take the average of this, so answer equals total of all numbers divided by the array of numbers length, aka the total amount of items that we have. And then we return the answer. So this should come out as 1. And it does. Nice. Alright, and then let's make this one 50. See what it does. The average is 10. Note to put here, integers can't be divided into decimals. It'll just chop off the decimals when it does the math. So this might not be accurate, but you know, it does basically what we want it to. So now, you know, I can make these big, huge, long arrays. No matter what I do, because we've built something that allows it to replicate logic, it'll allow it to do the same sort of steps based on anything. I wonder what this will turn out to. 197, okay. So that's kind of the basics of functions. The thing to remember here, the signature, always add public static until we learn why not to. A return type, a name, and then arguments. Another cool thing that you can do, I'll mention this just so you can see it in action. You can have a return type of void, which is just a nice way of saying return nothing. So we do this, just it won't do anything. Well, it'll declare how useless it is, but there's no return type. If we try to set a variable equal to it, yeah, it can't, because void's not real. Void's in your mind. So that's you won't probably use this for the project, but if you like, you know, putting like big pieces of logic elsewhere, you can do that. I recommend doing it. I get yelled at work sometimes because I do it too much. I make too many functions and it's just hard to trace through my code because everything's put into a function somewhere. But, you know, if you're starting out and it's easy for you to organize that way, I really do recommend going for it. Keep opening that. Okay, so last slide. The anatomy of the function. We sort of went over this. Yeah, they sure are. Um, the anatomy of this function, I've spelled it out here, but it's it's a PowerPoint slide. What are you gonna do? Red corresponds to this, the function name. Green, the argument list, and pink, return info. How you return it, or what you need to return, and then the place you return it. If you try to give it a return type and never return anything, you're gonna have a bad day. So, this practice project is a little bit easier to do if you understand everything. However, I really, really, really recommend that you start this project the moment that you see this stream go up and the moment that you finish it, or that you finish watching things. Because if you don't understand something, it is very, very hard to wrap your head around these things. So, going over the project, create a function that can generate and return a random array of ints, ranging from 1 to 4, and the array size has to be between 5 and 10. Now that's tricky, because the array size being random is something that you've only seen once. I'll give you a hint. It has to do with how we implemented it here. That integer can be changed and randomized. Create a function that then uses function 1, adds up all the numbers, and returns the result. So this is pretty simple. Your function 2 is just going to gather up the array and figure out how much the total is if you add everything together. But the key part here is that you'll have a function calling another function. Now the third part, create a function that creates an array of results from function 2 with a size of 5 to 25. And then it will print each result to the console. Hint, hint, I've console written in a function before. It is pretty easy. I'm not going to tell you guys exactly how to do it. I'm not going to give you guys any more hints than just you can review the stream. But it's not a bad situation. At the end of this, you should have 3 functions, and your main should essentially look like this. You'll have a lot of code down here, but your main thing from this bracket to this bracket should just say something like function 3. And that's all. If your main has anything else besides this, there's probably something going wrong and we should talk about it. Anyway, thank you guys for joining live. At this point, if you guys have any questions, I really recommend that you ask them now. Hopefully we can get some common issues people might have out of the way, and then people who are not able to make the stream can watch it. No questions so far. I'll give it another minute, and if anyone asks anything, we'll reset that timer. So you say dictionary. Oh yeah, for this assignment you do have to use just arrays. Dictionaries are useful, but that's an advanced topic. I will touch on it a little bit because you brought it up. Dictionaries are a type of array. I mean, not exactly, but they're a collection. They're really cool because a dictionary, instead of using just like integers to index into it, you can use other pieces of data. But we'll deal with that. Actually, probably never. If you want to learn it, you'll have to learn it yourself. That probably won't be covered in this quote unquote course. All right, that minute has passed, and I guess technically you did have a question. Okay, we have till 6:38. All right. It doesn't look like anyone had any questions, so I'm going to end the stream here. Thank you guys for coming. Again, really recommend you get started on this as soon as possible. Same as always, if you know what you're doing already, this is not anything new to you. I really hope that you reach out and help the people who it is new to. Eventually, we're all going to need help, but this is meant to start from raw beginners, transition you into making your first game. So thank you guys. I'll post the assignment links in the Discord, and let me know if you have any questions.